Welcome to the Scalar Learning Podcast, your central hub for all things related to education. Join us every episode for the most up-to-date tips and strategies on how to maximize student potential. Sit back, listen, and enjoy.
Scalar learning, give me that scalar learning. Scalar learning, give me that scalar learning.
What's up, everybody? Welcome back to another episode of the Scalar Learning Podcast. I'm your host, as always, Huzaifa. Today we are talking about standardized tests, and in particular, we are talking about the new SAT. So for those of you guys who are unfamiliar with the fact that the SAT has been completely redesigned and changed up, let me give you a quick summary of what's gone down. So back when I took the SAT in high school, it was out of 1,600 points, and they had a math section and a verbal section like they still do today. Shortly after I graduated high school, they changed the test to be a 2,400 scale. And with that new scale, it had two verbal components and a math component. And it was kind of like, so again, 1,600, not 2,400. I think a score around a 1,400 would have been around a 2150, something like that. So everything had been scaled up, and it was roughly the same percentiles with these new scaled scores, so on and so forth. In March of this year, in March of 2016, the College Board decided to release a new and improved version of the SAT. Why they did this, I don't know exactly for sure. The claim is that from the College Board that they did it because they wanted it to reflect more real world applications of both English and math. So for example, a lot of the math problems are now ostensibly focused on real world applications. I have heard rumblings that it actually has been changed because of the decreased popularity, the decreased enthusiasm of students to take the SAT versus the ACT. Again, when I was in high school, pretty much everybody took the SAT, and the ACT was more of an afterthought. In fact, a lot of schools didn't even accept the ACT back then. Now everything is different. They accept either or, and the ACT has been gaining a lot of popularity. So I believe that this is as well a business decision on the part of the College Board to revamp and revise the SAT so that it is once again the test of choice for high school kids. It's kind of funny because I know probably most kids aren't super eager about taking the SAT or the ACT for that matter, but that I believe is the main reason why it was redesigned. So what am I going to talk about today? Today I'm going to talk about what exactly has changed, what you can expect to see on this new version of the SAT. And I've studied it in depth. I've seen it. And I can tell you from my perspective exactly what has changed with some general references. And then I'm going to get into the nitty gritty because I've actually performed I've run the numbers on the breakdown of the test questions based on the College Board's own new SAT book, which has 4 sample tests in it. And so I ran the numbers just like I did on the old version of the SAT, and I saw some pretty dramatic differences as far as distribution of question types, which is pretty interesting. So in some of the articles that I've read, people talk about how the math section has changed, but changed the least compared to the other sections. While that may be true, because the verbal sections have undergone a makeover as well, while that may be true, there definitely are some pretty important changes to be mindful of when we're talking about the new version of the SAT. So here's the gist of it. What's happened now is we have 2 sections with respect to the new SAT and 2 math sections in particular. So this is one of the major changes that has happened. We have 2 math sections. One of these math sections, by the way, is now a no calculator. You can't use a calculator. Now this is pretty new because before you could use a calculator on the sections in the math and it was fine. Well, now they're really emphasizing your ability to do mental math or math written down, whatever, without a calculator. So the new version, there's two sections. The first section, I believe, is 38 questions, and that is the calculator portion. I think it's 30 questions and then 8 grid-in responses or something like that, or 28 questions and 10 grid-ins. It's in that ballpark. And then the non-calculator section, that is 20 questions, 15 multiple choice, and then 5 grid-in. And that gives you a total of 58 questions. So the new math section, there's 58 questions. And I've seen it. I've taken a bunch of the practice tests for the non-calculator section, and it's fine. You don't need a calculator. You really don't. As long as your mental math and your ability to do calculations on paper is decent, you're going to be fine. You're not, supposedly you don't even need a calculator for the calculator section. That, I would say, you're better off having a calculator just to reinforce the calculations, even if you are trying to do them yourself, just to reinforce that what you've gotten is actually correct. So that's from a high level. And again, now they've changed the score from 2400 back to 1600. So you can get up to an 800 on a math and an 800 on the verbal. And the max score you can get combined is, of course, 1600. So just like back when I was a youngin, when I was in school. So let's go into some detail now about specifically what's going on with the new math section. So here we go. There are now multi-step problems that ask students to take multiple mathematical steps. So actually, this existed too. Of course, there were multi-step problems in the old test, but now there's a greater emphasis, I should say, on being able to jump through a set of steps. Now, another thing that we see is a new addition is there's now trigonometry on the test. That's new. That wasn't there before. Mind you, it's relatively basic trigonometry. So we're talking about being able to understand and know sine, cosine, and tangent. If you're unfamiliar with these, you can watch some really great videos. I have a SAT course as well and an ACT course on Udemy. You can check those out and see I think I'm going to try and make the trigonometry video available on YouTube as well for free so you can check it out. But the gist of it is you want to become a little bit familiar with how to use sine, cosine, and tangent. The unit circle would be nice. It's not essential that you understand it. And another thing that I've noticed that is tested here and there is negative and positive values for sine, cosine, and tangent. So depending on what quadrant you are with a particular angle, whether you're in the first quadrant, second quadrant, third quadrant, or fourth quadrant, sine, cosine, and tangent will either be negative or positive. This, for whatever reason, is something that I've seen the College Board test, and they like to test this concept. So a quick review, and hopefully if you can memorize how that works, you'll be good to go. If you don't want to actually memorize it and understand exactly why sine is positive in quadrant 1, why tangent is positive in quadrant 4, so on and so forth. Tangent is actually positive in quadrant 3. So if you want to understand why these different positive and negative values exist, I encourage you to do so. I'm not going to talk about it here because it's hard to explain without visual aids, but I encourage you to do that so you don't have to rely on rote memorization. So that's the gist of it. So now there's also, I'm going to talk about some other things that a bit more specific. What you'll notice is on the new version of the SAT in the math portion is a greater emphasis on data interpretation and graphs. So what I like to call data analysis. Now I'm going to go into the numbers shortly, but we have a much greater emphasis on being able to understand real world data. So again, this is done for the purpose of basically being able to use math realistically. How would you use it in science and when you're taking studies, when you're trying to analyze data? So they have more questions on this front. You'll also have a lot more emphasis on being able to understand what a formula is all about. So basically deriving a formula or understanding a formula. That was something that was really surprising for me because I'm not accustomed to seeing these types of problems. So that's pretty interesting. Like, for example, if they give you a formula and let's say it's y equals 3x plus 7, and it's modeling some type of behavior, they'll tell you what it's modeling. Then in the question, they'll say, what does the 3 in this equation represent? What does the 7 in this equation represent? Something like that. It's actually pretty cool because it does force an understanding. It requires you to really dig down and understand why formulas or equations are set up the way they are. And I think this is important because later on in life, when you do want to use math to perform some analysis or arrive at a particular answer, I think this would be really helpful if you've got a great grasp of exactly how to break down and understand questions. Understand exactly how formulas are created and so on and so forth. Okay, now what I'm about to do is I'm going to go over some of these really awesome analytics that I think are pretty insightful. Again, this is data that I've collected myself in my own research. This is a lot of times data that I have to collect when I create my courses. So my video courses on the SAT and the ACT, soon to be released on the IC for the middle level, they're founded on a premise of frequency. So, and what I mean by that is the information in the courses is presented in the order of the most prevalent question types down. So the reason why I do it this way is because usually kids who are taking the SAT or these other standardized tests, usually they know all the math or they've studied it at some point, but they may have forgotten it, or maybe they're learning a little bit. But the idea is you can pretty much jump around and you don't have to follow a particular order. You don't have to teach in terms of pre-algebra, then algebra, then so whatever the basic order or format is in typical schools, because everything is there. It just needs to be refreshed. And so the way that my courses work is, hey, I'll tell you what I think is probably going to be most prevalent based on these analytics and this analysis. And you can then study in a top-down fashion. So you can devote time where time is best spent. Okay, so now I'm going to go through some of these numbers that I've unearthed and really talk about what has changed, what has been modified most, where you can see the biggest differences in terms of distribution. So I'm going to start with my old analysis of the old exam, and I'm going to explain what the big topics were there, and you're going to see really how it's been just totally redistributed. So the biggest topics when I did the initial analysis on the old version of the test, the biggest topic was graphs and coordinates tied with triangles. Okay, so graphs and coordinates used to comprise around 9% of the problems, 9.26% of the problems to be exact. And I got almost the exact same calculation for triangle problems. Now, when I say graphs and coordinates, I'm talking about questions that involve slope, that involve linear equations primarily, but that can also involve graphs of quadratic equations and how to use different formulas, for example, to calculate the distance between 2 points, stuff like that. When I talk about triangles, I'm talking about all principles involving right triangles, 30, 60, 90 triangles, 45, 45, 90 triangles, how to calculate the length of a hypotenuse if it's a right triangle, what is an isosceles triangle, what is an equilateral triangle, what do all the angles in a triangle add up to. So these two categories had a pretty heavy amount of questions devoted to both of them. We also saw circles have the geometric concept of circles, what's a radius, diameter, how to calculate arc length, sector area, so on and so forth. That had about 5%. We saw a heavy emphasis on single variable equations, multivariable equations. Both of those had 5% in each one. And we saw a pretty big emphasis back then too on data analysis, 6.3%. So those were the really big categories. And everything else fell off pretty substantially. We had a decent amount of stuff on angles, there's general angle properties, how to look at angles using a transversal between parallel lines. And it was there was another big topic was number properties. That again also comprised about 5% of the questions. And when I talk about number properties, I'm talking about how to distinguish between integers, real numbers, prime numbers, figure out prime numbers, odd numbers, even numbers, things like that. So now I want to talk about how it's been changed. So now we're going to go through some of the new numbers, and I think you're going to find this pretty interesting. So the biggest thing, and this is a category that was barely, it was there, but it wasn't that prevalent. The biggest change is the deriving a formula category. These are, again, categories that I've come up with the names, so you may not see them in other literature, but deriving a formula, which is where you learn how to decode word problems and derive a formula when need be. It's also about understanding equations, understanding how to, like I said before, understanding what the 3 in 3x plus 7 means, what the plus 7 means, so on and so forth. This now accounts for a staggering 14.18%. So that's massive. That's massive. That's more than any other old category. So you can tell what the SAT, what the College Board has done. They've really shifted the emphasis here in particular. So I really, really emphasize that you try a lot of these problems. They're all over the place in the College Board's practice SAT book. You'll notice they're big paragraphs, and they really involve not only an understanding of math, but a good comprehension of being able to read effectively. So deriving a formula, that's a massive one. Another big change, we have data analysis, as I mentioned before. That comprises almost 9.77%, almost 10% of the problem. So this is decoding bar graphs, tables, pie charts, and other vessels of data, and being able to look at the data, make predictions from it, analyze it, understand it. A great way to practice for data analysis problems, other than just doing the SAT problems, is even looking at the science section of the ACT. So the science section of the ACT, it's not exactly about understanding biology or chemistry and memorizing a bunch of facts. It's really about being able to read passages that are related to science, read bar graphs, so on and so forth, and being able to understand that data and then apply it to questions. So these are two huge categories. These categories alone comprise 25% almost of the questions that you're going to see on the SAT. So massive. You just tackle these types of problems alone, and you're setting yourself up in a really good, really positive way. All right, the next big category that I noticed, this is, again, a huge jump, plugging in values. So when I talk about plugging in values, I'm talking about taking an equation, y equals 3x plus 7, we'll use that again, and then it might say something like, okay, so what does y equal when x equals 2? So 3x plus 7, so 3 times 2, which is 6, plus 7 is 13. So it's a very simplistic example, but you'll get these different types of problems with slightly more complex formulas, but not that much more complex, and you just have to plug a value in and see what the output is. So this is pretty substantial. Now, almost 9% of the problems are now plugging in values. And once you get a lot of practice with these types of problems, I think you'll find that you'll be able to navigate through them with a pretty high level of accuracy. You just need practice. It's really about having a lot of attention to detail and not slipping up in a minor way when you are trying to process these formulas. Okay, so that's number 3. Number 4, another huge change, massive change. The number 4 category is now quadratic equations, which comprise 8.45% of all test questions. Again, huge change. So now I've just listed 4 categories that are all above 8%. So if you remember, with the old numbers, there were 2 that were around this level, just above 9%, and that's it. And everything else was distributed in these different ways. But that's massive. So if you add these up, let's say 999, and that's 27 plus around 14, 37. 4 categories comprise almost 41%. So it's a big deal. It's a very big deal. When we talk about quadratic equations, we're talking about an equation that begins with x squared, where the highest degree is 2, so it won't have anything greater than x squared, but it'd be something like y equals x squared plus 2x plus 4, something along those lines. In order to handle these types of problems, what you're going to want is a good, solid understanding of how to factor quadratic equations. And again, this is something that I can't explain over the podcast, but there's lots of great videos and materials on how to factor effectively. I would recommend, you don't have to necessarily, but I would recommend knowing the quadratic formula. And the reason being, there's other ways to solve quadratic equations, but the quadratic formula, if all else fails, it will always work. If you can't factor, usually you should be able to on the SAT, but if you can't, even if you can, the quadratic formula will never fail you. It will always work. There's these other methodologies that people use, like completing the square, so on and so forth. But at the end of the day, they're more or less superfluous because the quadratic formula will always get the job done. All right, the next big category is what I call multiple functions. We could also call it composite functions, nested functions, and then also I lumped into this systems of equations. So these are usually two or more equations, usually just two, where you have to find values that will solve both of these equations. So for example, you may have two linear equations, and what we're really looking for from a graphical standpoint is we're looking for if there's two linear equations, meaning two equations for lines. That's why we call them linear equations. If you have two lines, we're looking at the point of intersection. We're trying to find that, usually algebraically, not graphically. So when we're solving systems of equations, there's some cool strategies that you can use to do it algebraically. One is called elimination. The other one is called substitution. And again, you can look this stuff up if you need a refresher. And that's what a lot of these problems focus on. Same thing when we're talking about composite functions or nested functions. You're now taking two functions and it's like you're plugging one into the other. You're plugging a function into a function, which is pretty interesting. And it's not that complicated, by the way, once you give yourself a nice review. It sounds, I guess what I mean to say is it sounds a lot more complicated than it is. But with some good practice and some good review, you'll be fine. You'll be totally fine with this stuff. All right, the next category that also has a pretty big distribution, 6.85%. is graphs and coordinates, our old friend from the first run of numbers. So it used to comprise about 9%, now it's 6.85%, so it's still pretty heavy. And the way I've described it in my course is understand any and all problems relating to graphs and coordinates of functions. The next category, that's pretty substantial again too, around 6%, is percentages, fractions, ratios, and proportions. Kind of lumped all those together into one category. So it's still a big deal. We're still talking about a relatively high number, a relatively high percentage. So if you need to shore up your understanding of adding, subtracting, dividing, multiplying fractions, percentages, decimals, all that stuff, I'd say do so because it does have a pretty big presence on the SAT. The next section is single variable equations. So this is something where you just usually have one variable that you're trying to isolate and solve for. And it uses very typical variable isolation strategies. So this was a big one in the old version, still a big category, 5.45%. It's pretty substantial. So if you need a refresher, again, I would say go get one. And the main idea here is we're always using inverse operations. And we're trying to isolate. This is really tough to explain again without visual aids, but the idea is if you're trying to get x by itself and you're adding, and right now it's got something being added to it on one side of the equation, you're just going to subtract that value. So let's say it's x plus 3. You're going to then subtract 3 on that side and the other side. And that's the inverse operation of addition, of course, is subtraction. And now you can get x alone and get that 3, sort of bump that 3 to the other side of the equal sign. So that's the idea there. Those are the major categories. The next ones are that I have written down. We've got word problems, 4.69%. We've got multivariable equations, similar to single variable, just going to have two or more variables in these equations. And sometimes you may be isolating one of the variables in particular. They seem to like that a lot. Another big category is mean, median, and mode. Not big, I should say, but it's there. It's about 3% of the questions. So just understand the difference between mean, median, and mode and how to apply it to data analysis. And it's I'll give it to you real quick. Mean is the average. Median is middle, the middle value. If you have 11 values, it's the value that will fall right in the middle if you arrange those values from least to greatest. That is the median value. And mode is the one that occurs most frequently. So if you have a basketball team where let's say it's a 10-person basketball team, 3 of the guys are 25, 4 of the guys are 20, and the remaining 3 guys are 40, then the mode would be 20 years old because there's 4 guys who are 20, and that's more than the other 2 ages. So the mode is the one that occurs most often. And then we got circles coming in, right? Circles, you see a pretty big drop at 3.1%. Triangles have dropped all the way down to 2.91%. That's a huge drop. So it went from basically being the top category, the most tested category, to now the 13th most tested category. That's a pretty substantial drop. So they used to really love triangles for, I don't know why they've de-emphasized it so much, but they have. And then we've got trigonometry. Like I said, that's a new category, and that sort of snuck in there at 1.22%. So not major emphasis, but it's there. Another new thing that I didn't see before is there is a bit of inclusion of imaginary numbers. And I'd say it's just under 1%. So it's not a major amount of imaginary numbers, but it's there. So I definitely recommend you just quickly brush up on what those are and how to use them, so on and so forth. So that's about it. That is the new version of the SAT, in particular the math section. So I hope this was helpful for you, especially if you were thinking about taking the new SAT and want to understand exactly how to prepare for it in an optimal way, using your time effectively and efficiently. I definitely recommend, since it's now the beginning of the summer, that you take the summer to really prepare, really do your homework, take a bunch of practice tests, sign up for a course with any number of companies. It's all going to be good, but it's really going to come down to the amount of time and effort that you devote on a personal level. So that's it. Check out the show notes. Go to www.scalarlearning.com. And again, as always, if you have questions or comments for me, email me at huzaifa@scalarlearning.com. Would love to hear from you. Thank you so much for joining me. See you guys next time. Take it easy.
Scalar learning, give me that scalar